Communicating the complex narrative of the future of energy and climate change has been a significant challenge. Broad groups of interested partners, often faced with multiple competing narratives, have made it difficult for the public to understand the already complex topic of energy modeling. Helping people understand trade-offs and connections between their actions and future outcomes is critical to making changes for a better energy future. In considering a more sustainable future, many regions are faced with a remarkable array of policy decisions, energy portfolio options, and greenhouse gas reduction techniques. For this challenge, we partnered with local nonprofit organization Michigan Energy Options and the Mid-Michigan Program for Greater Sustainability. Michigan Energy Options needed a way to communicate with a significant and passionate group of stakeholders who need ways to understand and participate in the city's energy future. Michigan Energy Options has helped more than 1 million people in Michigan conserve energy, save money, adopt renewable energy, reduce greenhouse gases, and lead more sustainable lives. We were also joined by the UCSB McClintock Lab, the designers and hosts of the C-Sketch online platform. For this Climate Resilience App Challenge, we are submitting the CommunityViz Web App, a tool that planners can use to open up new opportunities for education, citizen engagement, and policy change. The Web App Publisher is an all-new wizard for desktop CommunityViz that makes it incredibly easy to export your analysis results to ArcGIS Online and view with the Web App Viewer. The Viewer is a custom app available from the ArcGIS Marketplace. Using the outputs of the Web App Publisher, this template provides the ideal way to show your work to broader audiences. It's attractive, friendly, and mobile-ready. CommunityViz Web Apps are custom web templates that extend ArcGIS Online to provide CommunityViz-based content and functions. The Web App Publisher, a desktop-based CommunityViz presentation tool, fully automates the process of publishing a desktop analysis to an online web app. CommunityViz Web Apps are a great way to quickly share your analysis results with your ArcGIS Online Organization, selected groups, or the general public. The Web App Publisher uses visible map layers that have been turned on, visible attributes in visible map layers, scenarios, indicators, assumptions, and analysis information such as authors, descriptions, and tags. The Web App Publisher wizard allows you to quickly set up and edit the analysis components, ArcGIS Online publishing options, and the web app setting that you would like to view online. After clicking Finish on the wizard, the analysis information will transfer from your desktop to the cloud. On the CommunityViz Web App Viewer, you can pan around the map, change the base map, view the legend. You can also change scenarios and get easy access to selected indicators, assumptions, and description and information. In this example, we'll see 3 scenarios. The analysis considered a large 3-county region around the Lansing-East Lansing metropolitan area. For this example, we focus on a subregion around a corridor centered on Michigan Highway 43. Placeways and MEO gathered the necessary data and incorporated this data into a GIS to build the spatially enabled load and resource model. We incorporated the resource portfolio types such as reducing coal consumption, increasing wind energy, or increasing the percentage of rooftop solar, as well as efficiency measures such as increasing the Energy Star certified buildings or changing user behavior. The base scenario shows what residential greenhouse gas production looks like in the present day based on the number of households. The energy model is built on a basic energy profile for different types of housing. Single-family housing, multifamily, and manufactured homes are all included. Each home profile has basic assumptions about the number of appliances, light bulbs, heating and cooling systems that all make up the energy consumption patterns of an average household. The Mid-Michigan region is served by a number of different utilities, each one with its own mix of generating facilities. This is called an energy portfolio. The energy portfolios for most utilities in this region rely primarily on coal, with some natural gas, nuclear power, hydroelectric, and a handful of renewable sources such as wind. With the portfolio information, we can calculate how many greenhouse gases are generated total and per household. With spatial household information, we can see how many tons of CO2e, or carbon dioxide equivalent, a common measure of greenhouse gases, which can be attributed to each neighborhood. A separate model based on jobs looks at commercial use. In this particular example, we're just looking at residential. The next scenario shows what energy consumption looks like in a business as usual scenario. This scenario assumes that population growth will occur and that energy consumption will occur at pace with population growth. This shows energy use growing as the number of households grows. The final scenario explores a what-if scenario. In this scenario, we'll look at the effects of a new policy measure aimed at increasing the energy-efficient lighting in residential households. We'll call this a strategic measure scenario. In the next tab, in Indicators, we can see the differences between the scenarios shown in a graphical form. The first indicator shows an annual total of residential energy consumption in megawatt hours. The second indicator shows tons of CO2 emitted. You can see that the business as usual scenario performs worse than the current scenario, and that provided that we enact this strategic measure, we can actually lower the consumption of energy and also the generation of greenhouse gases. Under assumptions, you can see the key assumptions that we use to build the lighting efficiency measures: the number of lights per different types of households, what type of lighting is each type, so fluorescent, compact fluorescent, LED, etc. We also have the average number of light bulbs per the different types of residences, whether it's single family, a manufactured home, or a multifamily residence. We also have the target take rate among residences. This is the target percent of households that adopt a greater proportion of high efficiency light bulbs. In the final tab, we have description information: the author, the date, who to contact, a brief description. We can also post here short descriptions about each scenario and what they imply in terms of the energy footprint and greenhouse gas generation for the whole region. Our approach incorporated local stakeholder preferences and was customized through an initial scoping period. Placeways and MEO gathered information on policy options, renewable energy types, efficiency measures, and future scenarios. This example could have easily incorporated other efficiency measures or behavior changes, such as increasing the number of certified buildings, implementing more rooftop solar, or exploring changes to the current energy portfolio. And we could publish all this to our ArcGIS Online account using the CommunityViz Web App Publisher and the CommunityViz Web App Online Viewer. Thank you for hosting the Climate Resilience App Challenge, and it was a pleasure to participate. Please contact us if you have any further questions.